Alright guys, we're going to go ahead and run through this activity that we did in class together. There were two big portions that we're going to go ahead and take a look at that will be highlighted on your quiz and test. The first one has to do with energy transfer and phase changes. So let's take a look at the diagram here. We're going to focus in first on going from the ice into the liquid. When you go from the ice into the liquid, you're going from a solid into the water. That is melting. And the reason why I made it red is because that will involve absorbing heat. The ice will absorb heat. It will phase change into water. Same thing is happening when you go from the liquid into a gas. The liquid is going to absorb heat, and it will phase change from a liquid into water vapor or gas. And now we're going to go back the other way. When you go from a gas to a liquid, the gas is going to release heat, meaning it's cooling off, and it's going to phase change from the gas back into the liquid. And then on the other side, if that liquid continues to lose heat, then it will turn back into a solid, which we call freezing. Here are all those processes spelled out for you. This is important when we start talking about energy transfer in the atmosphere, how things evaporate, how they condensate, absorbing heat, releasing heat. So we did an activity to model energy transfer and phase changes. Let's go ahead and take a look at this. We started out by turning on the heat lamp. Heat lamp sent out radiation or heat right into the water. And what happened at that point is that the water absorbed the heat from the heat lamp, and then that water eventually evaporated. There's our phase change. And it happened again because it absorbed heat. Here's our water vapor cruising around in the tank here, that evaporated water vapor. But then something happened. As it was moving around in the tank, it reached this area of cooler air because of the ice. And what happened is that water vapor then released its heat into the ice. So the ice absorbed the heat. How do we know? It melted. And as a result of that water vapor giving off its heat, another phase change happened where the water vapor condensated back into water droplets. So if we take a look, we have pretty much everything going on here in this model except for freezing. We have radiation, our source of heat. We have absorbing heat into the water. We have evaporation turning into water vapor. That water vapor then released its heat into the ice, which absorbed the heat and it melted. And because that water vapor released its heat, it condensated and it turned back into water droplets. Again, the only thing that we didn't model in this whole activity was freezing.
The last point to make here, and it's probably the most important point, is to realize that all four spheres can be represented within this model, and that the water cycle, or this model, can connect all four spheres. For example, the water represents the hydrosphere, and within the hydrosphere, in nature all the time, because of the sun, the radiation, the water is always absorbing heat and evaporating and releasing heat. And the sand, well, that represents the geosphere. Now, if we put a little person right here, well, now we have the biosphere. Now, if there's enough condensation that happens or releasing heat, then rain can go down onto the biosphere and help the trees grow or affect the little person that's right here. It could also affect the sand or the geosphere by washing it away, causing erosion or to reshape the land. We also have the atmosphere represented here, and that's all the air that's inside of the box. And of course, there's energy transfer happening there with absorbing heat and releasing heat, and there are phase changes with the atmosphere and the biosphere. So we got all four spheres represented, and that's probably the most important part to realize is that this model is a connection between all four spheres of energy transfer and of matter.
Hope this helps you out for your quiz.